Hi, this is Mrs. Meyers, and today we are going to be learning lesson 1.4, measuring angles. Our target today is to find and compare lengths of segments and angles. So an angle is formed by two rays with the same endpoint. We're going to write the word angle in here. The rays are the sides of the angle, and the endpoint is called the vertex of the angle. So I think you've seen an angle before. If we look down at this angle here, the vertex would be angle A, the sides would be ray AB and ray AC. So there are three ways to name an angle. This angle here, we could name it, first of all, using the three letters that form the angle. And in this case, the angle needs to be named in order with the vertex point A in this case, as the second letter you name, the middle letter. So this angle would be called angle BAC. If you think about how this notation makes sense, we start at angle B, we go to A, and then to C, and that draws the exact angle that we're talking about. So remember, these notations make sense. It's like you're giving directions. Start at B, go to A, then to C. We could go the other way, angle C, A, B. Either one works. The second notation we use for naming an angle, we could call this angle 1. Not all angles are going to be labeled with a number, but this one has a number 1 right here, so we could call it angle 1. The third way can't be used all the time, but we could call this angle A. So just using the vertex of the angle. And this can only be used if that vertex is only the vertex of that one angle. So only if it is the only angle in the diagram with that vertex point. Okay, continuing on here, the interior of an angle is the region containing all of the points between the two sides. So the interior is going to be, if you look at the diagram here, here's our angle. The interior is going to be all of these points that are inside here. So this is the interior. If you think of it as like a alligator mouth, interior is everything that would be inside the mouth. Exterior is going to be everything on the outside of the mouth. Okay. So if we try these problems based on what we just learned, what are two other names for angle 1? So here's angle 1 right here. How else could we name this angle other than angle 1? I will give you one example. Angle J, M, K. Start at J, go to M, end at K. So M is the vertex. That will be our middle number, our middle letter. You guys think of another way to name this. And you should have come up with angle K, M, J. We could go the other way. K to M to J. Same angle. Okay, the second question here says, what are two other names for angle KML? Guys, pause the video for a minute and think of the two other ways of naming angle KML. Come back and check your answer. And you should have come up with angle 2 and angle LMK, just reversing those letters. Okay, would it be correct to name any of the angles in this diagram angle M? And in this case, no, because angle 1 and angle 2 both have point M as their vertex. So since both angles have angle M as the vertex, you can't just say angle M, because you could mean angle 1. You might mean angle 2. You also could mean this whole big angle, angle JML. So you really just want to use the other ways of naming this angle, not using just angle M. Okay, continuing here, when we talk about measuring angles, we measure the size of angles in degrees with a protractor. So when you use a protractor, you're going to be able to find the measure in the angle, and I'm going to teach you that a little bit later. Angles with the same measure, so angles that have the same degree measure, the same size, are considered to be congruent. Don't know what that was. Okay, therefore, just like with segments, remember that if we measured two segments and they had the same length, like 5 inches and 5 inches, then we could say the two segments were congruent. Same thing is going to be true with angles. If their degree measures are the same, then they can be called congruent. This notation here is read the measure of angle A. Measure of angle A equals the measure of angle B. Then we can say angle A is congruent to angle B. And on a diagram, you are going to mark these with these little arches in the angle. So angle A has this arch, angle B has a single matching arch, then we know those two angles are congruent. In a diagram with more angles, we would just match the type of arches that we put. This angle is congruent to this angle, so we put a single arch. If we then want to say this angle here is congruent to this angle, we're going to put a double arch. Sometimes you might even see an arch with a tick mark going this way to match, and you just match up the symbols, then you know what's congruent to what. Okay, if we turn the page, we're talking about notation. Remember we said how important notation is. So the first one is just reviewing about segments. We have two categories in our table here. If we're actually talking about the object itself, the geometric object itself, the segment, we would call it, and we would write it, segment AB with this little line over it. If we were talking about the length of that segment, remember we are going to write this with no line segment symbol over it. This means the length of AB. Remember, in this case, if we're talking about, let's say, AB is equal to 5 inches, we could put a numeric value when there's no symbol over the AB. But if we have AB, the segment itself, we're not going to be able to say it's equal to something. We might be able to say that it's congruent to something. So a congruence mark is going to be okay when you're talking about the figure, the object itself. And an equal sign is going to be what we use when we're talking about the length or the measure of something. So the same idea is going to go with angles. If we're talking about the angle itself, you're going to be using just this angle symbol, ABC, or angle 1, or angle A, or however we want to name it in any particular case. That's the figure itself. If we want to talk about the degree measure, you use this little m, measure of angle A, B, C. So similarly to segments, again, in this case, we could use an equal sign. Maybe it's 52 degrees. And here, no little m for measure, but just angle ABC is congruent to maybe angle DEF. A congruent sign, an equal sign. Okay, this next chart here should be a review for you. I'm going to pause the video for a minute and fill this in, and then come back and copy it. Okay, so you'll see acute, right, obtuse, and straight angles. This first one, the acute angle, is a smaller type angle, and you'll see the measure of this angle is going to be between 0 and 90 degrees. Now, these symbols are less than symbols, so the measure of angle A is 0 is less than the measure of angle A, which is less than 90. In other words, it's between 0 and 90. The next one is the measure of angle B. The measure of angle B is a right angle. Notice this symbol, little square, means it's a right angle, and that tells us that this is 90 degrees. The measure of angle B is equal to 90 degrees. And the measure of angle C here is an obtuse angle, so that is going to be between 90 degrees and 180 degrees. And then a straight angle is exactly 180 degrees. Straight angle. Notice the vertex of this angle is point D. So this is an angle that opens up all the way wide to be 180 degrees. So the postulate that we need to learn here is the angle addition postulate, which may sound very similar to something we learned before, which was the segment addition postulate. Remember, the segment addition postulate said that if we have two parts of a segment, so a segment broken into parts here, then we said that the length of segment AB plus the length of segment BC equaled the whole thing, the length of segment AC. Well, with the angle addition postulate, it's a very similar idea. If you have an angle here, big angle that's sort of broken into separate littler angles, then the measure of angle AOB, which is here, plus the measure of angle BOC is here, equals the measure of the entire angle AOC, which is the entire big thing. So we're going to apply this here, problem 2A here, and we have some information given to us. The measure of angle ROT is 155 degrees. We're going to remember to do our Lisa. L for label. Label the diagram with the information they give us. They tell us this whole angle is 155 degrees. Then we're going to write our equation. Well, if that whole angle is 155 degrees, and we're using the angle addition postulate, which in this case is going to be this angle, measure of angle ROS, plus the measure of angle SOT, equals the entire angle ROT, measure of angle ROT. So if we plug in what we know, we will get our equation. ROS on the diagram is labeled 4x minus 20. And SOT on the diagram is labeled 3x plus 14. And ROT is our given information, is 155 degrees. Now, the reason, remember, sometimes we want to give a reason for why our equation makes sense. This is going to be angle addition postulate. So as we work through this, we're going to then solve. We need to combine like terms. 4x and 3x combine to be 7x. Negative 20 and positive 14 combine to be a negative 6. And that equals 155 degrees. In order to solve, we're going to add 6 to both sides. And we end up with 7x equals 161. To solve for x, we need to divide by 7 on both sides. And we end up with x equals 23. Remember A, Lisa, A, answer. We have to answer the question that was asked, and that is, what is the measure of angle ROS? Well, ROS is 4x minus 20, and TOS is 3x plus 14. So since we now know that x is 23, we're going to plug that in here and here. So 4 times 23 minus 20, and we get 4 times 23 is 92, minus 20 is 72 degrees. And 3 times 23 plus 14 is 69, plus 14, which is 83 degrees. So to answer our question, we have 72 degrees and we have 83 degrees. Okay, there's another problem for you to try on your own. I'd like you to pause the video and try this yourself and then come back. Check your answer. Okay, so hopefully you did this problem on your own and you followed Lisa. Notice it's a straight angle, which equals 180 degrees. So we label our diagram with 180 degrees here. And we write our equation accordingly. Our reason is the definition of a straight angle. We had to know that first. And the angle addition postulate, where we add the two together to make the big angle. You can check your work here, and our final answers were 142 degrees and 38 degrees. Okay, so you should be good to practice this on your own and fill in these answers here. We will check them tomorrow in class. And remember, if you have any questions, to write it down here, and I will answer those questions in class as well. There's another video about measuring angles with a protractor, and we will talk about that as well.